So here we're starting section 8.2, which is about the law of sines. The law of sines. So let's draw a triangle. And here this triangle is not necessarily having a right angle, not necessarily having a 90-degree angle. Let's call this side here A, this one B, and this one C. Across from A is little a, across from B is little b, across from big C is little c. And I'm going to drop a perpendicular line segment down from big C to little c. Should make a 90-degree angle right here. I'm going to call that H1. Okay, so I'm going to think about what's the sine of A and a big A. Well, big A is right here, and the sine of big A would be the opposite over its hypotenuse, would be H1 over B. And if we get H1 by itself, we basically bring the B up top on the left-hand side. We get B sine of A equals H1. Now something else we can find here. We can find the sine of B. Sine of big B. So here I got big B, and the sine would be opposite over the hypotenuse, right? H1 over A. And I'll bring A up here next to it, in front of the sine. I'll get A sine of B equals H1. So notice that these two things are the same, right? They're both H1. So I set them equal. I get B sine of A is equal to A sine of B. And now what I'm going to do, I'm going to bring a little b under here and little a under here. So I get sine of big A over little a equals sine of big B over little b. So a pretty cool little fact. Sine of A over A is sine of B over B. All right. Next thing's next. I'm going to get rid of this H1 right here. And this time I'm going to take a perpendicular line segment down from capital A to little a. It's a perpendicular line segment. That's a little 90-degree angle there. We're going to call this one H2. And this time we're going to focus on the sine of big B. Now keep in mind the sine of big B. If this is big B right here, we're going to be dealing with the opposite over the hypotenuse. It's going to be H2 over C. I can bring the C up here on the left, in front of the sine of B, so I got C sine of B is equal to H2. Also, let's find the sine of C. Sine of C, if you think about C right here, I'm going to take the opposite over the hypotenuse, H2 over B. And here I can bring the B up in front of the sine. I end up with B sine of big C equals H2. So notice that both of these here are equal to H2, so we can set them equal. They're both H2, so we get C sine of big B equals big sine of big C, and we can take C under sine of C and little b under sine of B, so we get sine of B over B equals sine of C over C. So we get sine of big B over B is sine of big C over C. So if you put these together, you get what's called the law of sines. You get sine of A over A equals sine of B over B, which equals sine of C over C. So this is the law of sines here. Very useful equation that can help us solve triangles that are maybe missing angles and sides. So let's do some problems involving the law of sines. Let's solve the following triangle. So here, number one, I got a triangle where little c is 6, big B is 50 degrees, and big C is 20 degrees. And of course, you want to have a calculator. Yeah, let's see if I got a calculator around here. I gotta have a calculator. So, let me draw my triangle. So we got A, B, C, let's see, little c, little a, little b, little c is 6, big B is 50 degrees, big C is 20 degrees. If I'm finding this, I gotta find big A, I gotta find little a, I gotta find little b. First thing I probably want to find is the big A, because I got two of the angles. When I got two angles, I can easily find the third angle by saying they have to add up to 180 degrees. Let's find big A. So I know big A plus 50 plus 20, all that adds up to 180. So that means big A plus, let's see, 20 plus 50 is 70. That adds up to 180, so if I subtract 70 from both sides, I get, let's see, 180 minus 70, that means big A is 110. Okay, then I gotta find, okay, I got big A and little b. What can I find? Well, I can find little a or little b. Doesn't matter. Let's find little a. So I have C is 20, and little c is 6, and then I have A is 110, and little a is unknown. So I got three of those things. I have one unknown, so I want to find little a. So I'm going to say that here, the sine of C, 20, over little c, 6, is equal to the sine of 110 over little a. So you see how I know three of those things. I have three of those numbers, but little a I don't have. So when that's the case, we can try to find little a. So what to do, I'm going to bring 6 up with the sine of 10. I'm going to take a up on the left side, and the sine of 20 I'm going to put under the sine of 10. Sine of 110. So I'm going to end up with a equals 6 sine of 110, 110 over the sine of 20. So I'll bring out my calculator. I'll do 6 times the sine of 110 divided by the sine of 20, making sure I have this in degrees mode, and I do. 6 times sine of 110, close parentheses, divide that by the sine of 20. So I get about approximately 16.48. Okay, So this is about 16.48. So last thing I want to do here, I want to find little b. So to find little b, I'm going to take, let's see, take the sine of big C again over little c, sine of 20 over 6 equal to the sine of big B, 50 over little b. I'll do the same thing. I'll do the cross multiply thing. So little b goes up there. I'm going to take 6 up on top on the other side with the sine of 50. And the sine of 20, I'm going to go on bottom under 6 sine of 50. So sine of 20 under 6 sine of 50. So plugging that in my calculator, in degrees mode, I got 6 times the sine of 50, close parentheses, divided by the sine of 20. And that's about 13.44. That completes my triangle. It gives me, I got all angles and all sides. Okay. We'll stop this video here and we'll put the